As equipment becomes larger and heavier, it also becomes increasingly difficult to lift and maneuver it in the confined environment of the coalface. In the absence of a universally accepted system, lifting operations on the coalface are either planned at a local level or improvised on site. This improvisation has inevitably led to a series of accidents. In an attempt to prevent any further incidents of this nature, a working party was formed with a mandate to develop a safe lifting system and to prepare notes of guidance so that the system can be implemented throughout British Coal. Two distinct areas of operation were identified as being particularly problematical: grading the armoured face conveyor and the installation of machinery and large equipment. Both of these areas were examined in conjunction with a number of manufacturers in order for them to design and develop lifting equipment. This will allow the safe working practices to be put into operation, removing the need for on-site improvisation. In addition, the working party also addressed the problem of how to attach the lifting equipment to the object to be lifted. Any improvisation of this attachment reduces the improvement in safety achieved when using the newly developed lifting equipment. Where possible, manufacturers were persuaded to incorporate lifting points into the design of their equipment. But for equipment already in use, it was necessary to devise new methods of attachment which could improve safety. Lifting AFCs through the short distances required for regrading readily lends itself to jacking from the floor, as there's seldom any need for lateral movement of the load under these circumstances. Many different designs of jacking apparatus were considered but rejected. Lifting such a wide load as an AFC in a stable, controlled manner invariably requires lifting points at both the gob and face sides of the AFC. Any designs which required equipment to be positioned on the face side of the AFC were dismissed because of the obvious dangers involved. Other equipment which could be installed and operated from the gob side of the AFC needed to be so large as to require major excavation underneath the pans for it to be installed correctly. Worse still, it was impossible to use because of the restrictions caused by the attachment of the chocks. One piece of equipment proved to have the solution to all these problems: purpose-made, correctly rated lifting bags. Being both flexible and less than 1 inch thick when deflated, they can be easily inserted under the AFC from the gob side, irrespective of any restrictions imposed by the chocks, and with only a minimal amount of cleaning out underneath the pans. The use of correctly sized bags ensures that the area of contact between bag and AFC is very widely spread. Also, because of their inflatable nature, the floor irregularities are easily accommodated. This allows for a very stable and safe lift. In order for the bags to work correctly, they require an adequate supply of water or compressed air at a maximum pressure of 8 bar. A special dedicated supply is used, which passes through a safety control unit containing a relief valve to ensure that this maximum pressure is not exceeded. They should never be connected to a full chock pressure supply and are fitted with a special quick release connection to help ensure that this is the case and that the safety control unit is not omitted. The bags obviously have a restricted lifting range, but this should not pose a problem when grading an AFC. The actual range of the lift is dependent upon the rating of the bag. The bag being demonstrated is the 20-ton type, which is 20 inches square and gives a maximum lift of 11 inches. Using these lifting bags allows the AFC pans to be raised to the required position. In cases where the range of a single bag is insufficient, the AFC can be supported using packing timbers. The bag can then be deflated and additional packing inserted underneath the bag to raise its position. Lifting can then continue, the bag being reinflated as before. When the AFC has been lifted to the required position, it must then be supported using timber packing, and the bag deflated and removed before any pushing over operations are carried out. The use of lifting bags for grading pans is to be adopted as the preferred method. However, it's not the only safe method, and where conditions dictate, then other methods may be used. For the purposes of installing machinery and other large equipment on a coalface, the chock canopies, either directly or indirectly, provide the only suitable anchorage point for lifting equipment. Two alternative methods of lifting are then possible, either using additional equipment as the power source for lifting, or utilizing the chocks themselves as the power source. The working party, in association with the two major powered support manufacturers, Gullek Dobson and MECO International, addressed the problems of designing equipment which could readily be attached to their existing range of supports. This particular point was very important, as any acceptable design would have to be capable of being used on supports already installed underground. One other manufacturer, R.B. Bolton, in association with the working party, explored the possibility of hydraulically down-rating the hydraulic system so that the actual lifting force it can generate is restricted to a safe level. Besides being able to be attached to any existing chocks, additional basic requirements of an acceptable design were stipulated. The lifting facility had to form an integral part of the powered support, and only operable when the support was set to the roof. In addition, it would preferably be adjustable to allow the point of attachment to the canopy to move along the region forward of the front legs to ensure a vertical lift. The design had to be simple and easy enough in operation to create a genuine desire for its use amongst the workforce, with the minimum amount of equipment to be fitted before it can be put into use. Gullek Dobson's design involved permanently attaching a hydraulic ram into a chock base and fitting two sprockets to the underside of the canopy. This allowed a 16mm chain to run from the ram vertically up to the canopy, horizontally underneath the canopy, and then vertically downwards to the load. A chain clutch arrangement on the lifting hook ensures that maximum use can be made of the ram's 500mm stroke, and the adjustable sprocket centers allows the lift to be as near vertical as possible. The hydraulic circuit for Gullek Dobson's equipment contains a yield valve to restrict the load to be lifted to a maximum of 5 tons, and also contains a non-return valve to prevent accidental lowering of the load, and an interlock with the leg circuit to ensure that the ram can only be operated when the legs are pressurized and set to the roof. As an additional safety feature, there's a manual release valve, which allows the load to be lowered in the event of the hydraulic supply being interrupted. MECO's design involved mounting a ram on the underside of the chock canopy, with an adjustable pulley positioned further along the canopy. The ram is positioned parallel to the AFC when not in use, so as not to cause an obstruction, and is swung round when required, so that it operates in line with the chock canopy. All the features of the Gullek Dobson hydraulic circuitry are included in MECO's design, i.e. yield valve, non-return valve, manual release valve, and an interlock with the chock legs. The MECO equipment has a slightly lower rated safe working load of 4.5 tons. Before any lifting operation can take place, colliery codes of practice must be drawn up. When lifting from the chocks with the Gullek Dobson or MECO International equipment, the code of practice should include the following key points. The AFC power supply must be isolated. The operator must ensure that all personnel are in safe positions. The support used for lifting must be set before any operation is undertaken. The positive set must be isolated. Only lifting equipment and attachments approved by the unit mechanical engineer may be used. If lifting from the last support at the end of the face, additional sideways restraint is required to maintain stability. In order to utilize the chock canopy as the lifting means, two basic criteria have to be met. The rear support legs must be fully pressurized and set to the roof. And the legs used for lifting must not be capable of exceeding the pressure required to achieve the maximum safe lift. An hydraulic system has been devised which utilizes solenoid-operated unloading valves located in the gate adjacent to the chock pumps to downrate the whole of the face line. This ensures that whichever chock is used, the nominated safe working load cannot be exceeded. In conventional operation, the main chock pump provides a hydraulic supply at normal operating pressure. In addition to this, a high-pressure pump provides the hydraulic supply for the high-pressure setting. With the solenoid valves in the de-energized state, all the chocks will continue to operate in this manner. To downrate the chocks, the 110-volt electrical supply to the solenoid valves is switched on. The solenoid valve in the high-pressure supply line becomes energized, diverting the fluid flow directly back to the tank. The valve in the normal pressure supply also becomes energized, reducing the pressure to a predetermined lower value, which is preset to ensure that when used for lifting purposes, the nominated safe working load cannot be exceeded. In this down-rated condition, the chock can now be used for lifting. Brackets designed to attach lifting chains are fitted into the keyhole slots on the side of the chock canopy, and the chock is then ready to be safely used as lifting equipment. Operation of this chock is normally carried out from the adjacent one, adding even further to the improvement of safety. All the operating valves need a pilot pressure to allow them to work. This pilot pressure is the limiting factor for down-rating the supports, as it's not possible to operate the support at pressures below the value of the pilot pressure. Before lifting operations with the support can be carried out, a code of practice must be prepared, which incorporates the following key points. The AFC power supply must be isolated. The solenoid valves must be energized to downrate the system before lifting. A sentry must be posted to ensure that the solenoid valves do not become de-energized. Additional temporary supports must be set before lifting. No normal chocking operations are to be carried out whilst the system is downrated. If lifting from the last support at the end of the face, additional sideways restraint is required to maintain stability. Having devised, designed, or identified suitable equipment which can be used for lifting purposes with safety, the working party have written some notes for guidance, advising how this equipment may be utilized for ensuring safe lifting operations on the coalface. These notes for guidance are intended as an aid for colliery managers and engineers in the preparation of local codes of practice, written to suit the specific requirement of individual collieries, and designed to eliminate improvisation and prevent any further accidents in coalface lifting operations. All lifting systems, both from the chock and with the chock, must be in full consultation with the powered support manufacturer.